Welcome back. A flex sensor is a device made of a thin, flexible material of which the resistance changes, it increases, as it flexes, hence its name. You can use these sensors to detect stress in machines or structures, but also in things like this power glove. There's lots of other uses, like in biometrics, in fitness products, and in gaming devices. Let's have a look at the flex sensor in action. You will need the Arduino, a flex sensor. You can get those for around $12 from SparkFun Electronics, a 1 kilo ohm resistor to build a voltage divider, and 3 jumper wires. Assembly is super easy. This is a sensor. You can see it's just a plastic object. You can bend it, doesn't break easily. It's got 2 pins which will connect onto the breadboard. It's very flexible. As you flex the sensor, its resistance changes, and that's what we measure, the change in resistance. So we just plug the sensor here, use the resistor to create a voltage divider, ground one end of the sensor, connect 5 volts power to the far end of the voltage divider, and then we'll take the measurement from the second pin of the sensor, the one where the resistor is also connected. So I'll plug that to analog pin 0. That's it. Now plug the Arduino into my computer and upload a simple sketch. Just takes a reading from analog 0. You can see as I'm bending the device, the readings in the monitor change. Here's a sketch. All we need to do is to read the voltage at analog pin 0 and print it onto the monitor. We'll start by opening up the serial port and setting its speed to 9600 beats per second, and take a reading from analog pin 0 using the analog read function. And I'm making a conversion here. The analog read function outputs values from 0 to 1023, but what I want to do here is to get the actual voltage on pin analog 0. So I'm using this simple arithmetic function to convert any value from 0 to 1023 to a value between 0 and 5 volts, represents the actual voltage. The result of this calculation goes into a local variable called voltage, which is of type float. And finally, I'm printing the reading out to the monitor. What's inside a flex sensor? Well, a flex sensor is made of carbon resistive elements, like the red, green, and blue in this representation here. So those elements are surrounded by a plastic flexible protective cover. So as the elements are bent, the resistance increases as a function of its radius because the resistive material becomes slightly thinner. Where the material becomes thinner, there is less carbon to conduct electricity, therefore the resistance increases.